Hello everyone, and welcome to this Spotlight presentation aiming to show you the value of design space exploration applied to CFD and using SimCenter STAR-CCM+. Change is happening faster than ever before, and this rapid evolution is having a significant impact on the way products are designed. Looking at the world around us today, we can clearly see some important trends that are driving companies to rethink their performance engineering practices. The globalization implies a higher competition requiring to drastically shorten time to market. It also drives an increasing demand for customization since people in different countries or regions may have different product preferences, forcing companies to manage many more design variants and ensure that all these variants will perform as expected. Our evolving world also imposes higher constraints with multiple ambitions, regulations, and standards. The fast evolution of new technologies and internet connectivity transform mechanical devices into smart systems of systems. And of course, there is one constant that remains: deliver innovations for these complex products while meeting the ever-increasing pressure on time, quality, and cost. To stay in the race, companies need to drive engineering innovation with the help of simulation and, most of all, design space exploration. Modeling real-world behavior of complex systems with an increased number of parameters is mandatory to fully capture product performances and make right engineering decisions. Managing multiple products and operating range variations is crucial to better answer new or emerging market needs. Increased product knowledge will also help reduce risk and increase reliability. But aren't innovation and cost reduction competing objectives? Well, we could think so at first glance, but with the right tools they are actually allied. This is why I'm here with you today to present you how our modern design space exploration technology will not only help you discover better and non-intuitive designs faster, but also allow you to better align resources and time with value extracted. Our modern and intelligent design space exploration is intended to build upon the strong capabilities that you've already established with modeling and simulation. It's clear that companies have already realized good value out of using simulation to validate designs, to troubleshoot challenging design flows, and even to predict the effect of certain proposed design changes. Industrial simulation adoption has grown tremendously over the years because of this value, primarily in reducing engineering time and cost by replacing physical prototypes and tests. But we are at an exciting time where there is a fundamental shift occurring in the strategy of simulation to drive greater product innovation. Companies are realizing that they can take their modeling and simulation initiatives to the next level by automating the design exploration process. In fact, after making this shift in simulation strategy, a growing number of companies are successfully filing and securing new product and technology patents based on findings from their design explorations. At Siemens PLM Software, we focus our efforts on understanding and removing previous bottlenecks to design space exploration, so this technology can more easily be implemented. We set our goal to deliver design space exploration solutions that would truly help engineers do real engineering and drive product innovation. So let's talk a bit more about the required steps to streamline the design space exploration process. To do that, we'll use a real-world example from Airbus. They set out to improve the performance of the bleed air system on one of their aircraft. The system takes in both hot and cold bleed air from the engine and mixes that air before delivering it to the cabin air conditioning and wing ice protection systems. The engineering problem at hand for Airbus was to redesign the mixing device and the bleed air system to ensure proper mixing of the incoming hot and cold air without introducing a large drop in pressure. Let's run through the required steps. First, you must be able to build a complete suite of virtual prototype variants. This process needs to be robust and simple to make multiple design changes since we are going to run hundreds of variants automatically. Second, you need to quickly and cost-effectively test these variants with multiphysics simulation. What's critical in this step is that there is no need to simplify the geometry and that you can include the necessary physics to predict real-world performance as well ensure a quick throughput of these virtual tests. Next, you need to efficiently and automatically search the design space for better families of designs. This process needs to be seamless and properly manage the resulting data, knowing that hundreds of design variants might be searched. Of course, once you have explored the design space, you need to have the ability to quickly assess the best families of design to gain the necessary engineering insight for making design decisions. So that's the process: build, test, explore, and assess. What's different about this process is the fact that it is streamlined and completely automated. This enables searching the design space for better families of designs before making any design decisions. So rather than needlessly spending time assessing the quality of an inferior baseline design and restricting your vision to only designs around that baseline, with this process you can cast a much wider net and search for better families of designs throughout the design space. This is the key to get the design direction needed to be innovative. For this example, after 280 design variants, a solution was found that reduced temperature variations by over 90% while still maintaining the pressure drop constraint. It's a straightforward concept, but using a modern process makes all the difference. In fact, in this case, Airbus initially attempted this problem by stringing together various tools in their toolbox: preprocessor, solver, post-processor, optimization, to look for design improvements around a baseline design. After 6 months, they got a result, but it did not provide the temperature uniformity desired, and the process was deemed too long, too cumbersome, and too fragile to use in practice, so it was shelved. By using our streamlined process that is centered on design exploration, Airbus was able to overcome the roadblocks they faced. So not only they reduced the temperature variations by over 90%, but because the process facilitates exploring designs throughout the design space, they were also able to achieve their goals and do it in only 10 days start to finish, meaning 13 times faster than without our solution. The impact of their paradigm shift in simulation on their business is then huge. However, still today, if we look at how engineers are spending their time with simulation, we'll likely find something like this. By far, most of the time is spent building the models and running that first test. So often, little time is left for exploring the design space and assessing results to identify better families of designs. As we've discussed though, the value extracted is much higher from time spent exploring and assessing, so there is a clear mismatch of effort expended and value. What's required is a solution that better aligns resources with value so that engineers can focus on engineering rather than building computer models. Armed with this knowledge and our decades of experience in simulation, we built a streamlined, robust virtual prototyping solution to help you successfully deploy simulation within your organization. But with our intelligent design space exploration technology, we're taking another step to help you easily go from one single simulation to many design variants in order to discover better design faster and align engineering time with value. To help you easily make this decisive and paradigm shift in your simulation strategy, it is crucial to understand what the requirements and obstacles of CFD-based design space exploration are. Obtaining and managing a parameterized CAD is the first mandatory prerequisite to start thinking about design exploration. The simulation process needs to provide an easy way to either build the parameterized CAD directly or to communicate with CAD packages to automatically transfer pilot design parameters to allow automatic CAD model updates. Design space exploration means geometry or simulation parameter changes that can be quite drastic. A robust and flexible CAD-to-mesh to simulation pipeline is then a mandatory prerequisite to allow flexible design or scenario changes. Exploring the design space means running dozens or hundreds of simulations. Thereby, the simulation process needs to be fully automated to allow an overall workflow re-execution and open the doors to design space exploration. Most of design exploration and optimization tools require high expertise to be able to choose and tune complex algorithms to get to a reliable result. Traditional algorithms and search techniques are most of the time too time-consuming and don't fit with tight project deadlines or complex problems with a high number of parameters. To be democratized, design space exploration absolutely needs efficient search techniques that are user-friendly, adapting to project time frame, and fitting complex problems. As we said earlier, exploring the design space means running dozens or hundreds of simulations. Distributed execution is then necessary to speed up the overall turnaround time of exploration studies. Licensing and hardware resource management are two significant pillars of this requirement. Efficiently post-process the results of your exploration campaign is crucial to make appropriate design decisions and increase your product knowledge. Design space exploration induces large amounts of data that need to be easily browsed and analyzed to quickly extract performance trade-offs and insights into product behavior. Finally, to empower engineers to do design space exploration at each step of the design process, it's important to have a solution easy to adopt and deploy with a streamlined process to effortlessly explore early and often, an efficient automatic search technology accessible to all users as we mentioned earlier. For those not familiar with the Siemens PLM software portfolio, SimCenter STAR-CCM Plus is our CFD-focused multi-physics engineering solution that uniquely integrates comprehensive physics with intelligent design exploration in a single CAD-to-solution environment built for the simplest to the most advanced CFD simulation needs. As you can see on the several examples shown on this slide, SimCenter STAR-CCM Plus covers a wide range of applications and industries such as ground transportation, aerospace and defense, energy, marine, chemical processes, and so on. Let's see how our customers leverage the power of SimCenter STAR-CCM Plus to easily extend to design space exploration. Our built-in design exploration offer is completely integrated in the same framework, the same interface, and the same workflow than SimCenter STAR-CCM Plus. It does not require any additional training and leverages all the power of SimCenter STAR-CCM Plus to easily access all stages of your virtual prototyping process from one platform, robustly re-execute pipeline workflows for fast design updates, and include parametric models with direct link to internal or external CAD models. This strong integration provides a familiar user interface with a consistent look and feel in order to enable a rapid pace of development. This way, you can seamlessly move from one single simulation to parameter sweeps or intelligent design exploration. SimCenter STAR-CCM Plus provides all users with an automated, integrated, and streamlined workflow to start exploring the design space on both existing and new CFD simulations. With the standard SimCenter STAR-CCM Plus license, you can perform CAD robustness studies to assess your model robustness prior to launching your exploration study, parameter sweeps or manual studies using geometry or physical parameters in order to automate the calculation of a set of points that you will define. With the STAR Innovate add-on license, you will extend to single or multi-objectives optimization studies using our intelligent search, design of experiment studies, also known as DOE studies, and stochastic studies. The STAR Innovate add-on license will also give you access to advanced design exploration post-processing capabilities. SimCenter STAR-CCM Plus gives access to a wide range of input parameters that can be exposed and driven in your exploration studies. Let's start with the first type of parameters called design parameters. For geometries built and parameterized directly in SimCenter STAR-CCM Plus using our embedded 3D CAD modeler, the related 3D CAD parameters can then be accessed and piloted. If you prefer to use your own CAD package, our CAD client's add-on licenses will allow you to access and pilot these external CAD parameters called CAD client's parameters. This bidirectional transfer of information between your external CAD package and SimCenter STAR-CCM Plus is available for NX, CATIA, Creo, and Inventor. We assumed here that you could easily create a parameterized CAD or obtain it from your design department. But often, we hear that this is actually an obstacle and that CFD departments struggle with dead or non-parameterized CAD. It's important to mention that our powerful synchronous technology provided with our NX CAD package removes this barrier by allowing you to easily and quickly create a parameterized CAD model from any non-parameterized one, from a native model, but also from models saved in standard formats like IGS, STEP, or Parasolid. Another type of parameters that SimCenter STAR-CCM Plus can pilot is the flight path parameters in order to drive part replacement in your exploration studies. Last but not least, simulation parameters will allow you to pilot boundary conditions, mesh, or physical parameters. This way, you have the flexibility to apply design exploration to many applications, analyze design and/or operating point conditions changes, or even speed up your methodology development process by piloting mesh parameters. During an exploration study, the model regeneration step typically completes in a few seconds, whereas the subsequent simulation for each design can take several hours. Clearly, a large number of errors in the parametric model can cause significant delays in your exploration study and also prevent the search from exploring good regions of the design space. The CAD Robustness study in SimCenter STAR-CCM Plus allows to easily and quickly evaluate the robustness of CAD parametric models to increase the quality of the search, ensure confident results, and avoid any resource and time wasting. This study can be performed before any exploration study type. For manual and sweep studies, all variants of the table will be generated. If you have a STAR-Innovate add-on license, you will have access to the Latin hypergrid sampling method, also known as LHS. Using LHS will allow you to carefully analyze the successful CAD regeneration rate and understand failures using a parallel plot. You can also use other sampling methods external to SimCenter STAR-CCM Plus by importing the resulting table of relevant variants to assess. Another key benefit is the efficient and flexible hardware resource management. SimCenter STAR-CCM Plus allows you complete control with its client-server architecture, allowing to connect to simulations and monitor runs. SimCenter STAR-CCM Plus is also flexible on how to use your computational resources. The local job submission is the traditional way in which it will work through your standard queuing system. The pre-allocation mode is a new innovative way of submitting a design exploration project by reserving the needed hardware and license resources via the queue. SimCenter STAR-CCM Plus will then manage the design run submission within the reserved resources. Let me show you what I mean by that. Using the general submission mode through the queuing system, you might experience delays from other runs submitted in the middle of your exploration study. Let's imagine we use the general submission mode to submit an exploration study with 4 simultaneous design runs represented by blue squares. Unfortunately, a colleague decided to also submit 2 external runs on using the same resources in the middle of our study. These external runs represented by black squares prevent our next design runs to use the hardware and license resources we initially planned to and will delay our exploration study. With the pre-allocation mode, you pre-reserve all the hardware and license resources you need for your exploration study upfront. It helps ensure an optimum turnaround time of your exploration study with an efficient use of your resources. From the SimCenter STAR-CCM Plus power sessions allowing you to run one job on an unlimited number of cores at a fixed price, to the SimCenter STAR-CCM Plus Power on Demand, allowing you to access SimCenter STAR-CCM Plus Power Sessions by the hour, or even with the SimCenter STAR-CCM Plus Power tokens, which will provide you with the flexibility to adapt the number of simultaneous jobs, pre- and post-access, and resource to use based on your workload and priorities. A broad range of flexible and innovative license schemes will help you deploy design exploration at affordable costs. Power tokens will help you to deploy all your available resources to maximize throughput when exploring design derivatives. They enable you to run any number of concurrent configurations of a design exploration study, each on as many cores as needed. This license scheme offers you a new way of managing efficiently your license resources. For example, with one SimCenter STAR-CCM Plus session and 8 Power tokens, you can run one design exploration study with 2 simultaneous jobs on 4 cores each, or run one design exploration study with 4 simultaneous jobs on 2 cores each, or run one design exploration study with 8 simultaneous jobs on 1 core each, and so on. This license scheme empowers you to adapt your configuration to your workload or project size, or even time frame, and easily deploy design exploration studies. Automated design sweep studies and manual studies are accessible to all SimCenter STAR-CCM Plus users for no additional cost. But with the STAR Innovate add-on license, you can go beyond sweeps and access directly in SimCenter STAR-CCM Plus our unique and intelligent search technology called Sherpa. To help convey the difference between our modern search technology Sherpa and the traditional design exploration, let's consider an analogy. Suppose you're tasked with climbing to a peak of an unknown mountain range. That's essentially what you face when you have a simulation model with an unknown design space or a response surface that changes every time you make a small change to the objectives, constraints, design variables, or variable ranges. Even though you don't know much about what terrain to expect, suppose that you have to choose one set of climbing gear and one climbing strategy. That's the traditional approach to design exploration. Even if software solutions offer hybrid strategies, they still contain predefined algorithms instead of adjusting to the problem at hand. What you actually need is a Sherpa who knows all the climbing strategies, carries all of your equipment, and can tailor your climbing approach to the terrain encountered. That's what the Sherpa method does by combining and weighting multiple search strategies, changing strategies as needed, and tuning the strategy to each problem. The Sherpa framework is both hybrid and adaptive, and it eliminates all of the previously described issues with the traditional approach. It simultaneously and automatically uses a blend of search strategies for global and local search performed together. By adapting its strategy to the design space and project timeframe, it leverages the best of all methods. This way, you can effectively manage simple but also complex problems and consider applying exploration studies even for highly time-constrained assignments. If a new search strategy is developed in the research world, we simply add it to the Sherpa framework and allow it to lend its advantages to any problem in combination with other strategies. Our technology does not require you to be an optimization expert, and the only inputs you need to provide are your variables, your project objective and constraints, and most importantly, the maximum time you want to allocate to your exploration study. The example running on this slide shows you how after 150 variations using our intelligent search technology, we've achieved a much better design than where we started. We achieved a 4-fold decrease in power consumption while maintaining blend time. Sherpa also includes a customizable way to exploit previous product knowledge to speed up and better drive optimization. You can insert designs of interest based on engineering knowledge or previous results into your design exploration studies. By incorporating information about the performance of a product upfront or during the study, the design exploration algorithms can more efficiently reach a better design. This is also useful if you are migrating from another optimization solution to SimCenter STAR-CCM Plus to ensure you don't lose your previous optimization results. Again, since everything is integrated in the same interface, the SimCenter STAR-CCM +1, it is very easy to transition from one study type to the other, making it easy to go from design sweeps to intelligent optimization. Powerful post-processing features dedicated to design exploration are available in SimCenter STAR-CCM Plus to empower engineers to easily navigate the results and quickly extract insights into trends and product behavior. X, Y, and history plots help analyze and compare results. Parallel plots aim to easily and quickly understand design dependencies and highlight common design trends. Pareto plots help to quickly visualize and understand trade-offs across designs for multi-objectives optimization. Interactive scene file and animation provide rich 3D analysis options. Interactive tables help quickly navigate designs while updating active scenes and plots based on the design selection. Synchronized views allow deeper visual comparison. You can have multiple ways to compare multiple variants at once in the same interface, visually or through tabulated values, quickly browse through designs to investigate differences and easily manage large amounts of data. With SimCenter STAR-CCM Plus, flexible options are available to help you understand your product, set of products, or system behavior. As we saw in the last slide, you can compare different design variants from one single exploration study at once. But you can go beyond that and also analyze results from different exploration studies to compare multiple designs, configurations, or load points at once in the same interface. On the right-hand side of the slide, we have 4 different rear spoiler designs. For each car design, we ran one parameter sweep study to vary the velocity. As you can see, we can directly in SimCenter STAR-CCM Plus analyze the results of these 4 sweep studies by comparing scenes side by side, but also by plotting all the information on the same plot to deeply understand our product behavior, for instance here, velocity versus downforce for the 4 sweep studies. To summarize, with SimCenter STAR-CCM Plus, you have now access to a full CFD-focused, streamlined and automated process enabling design space exploration. Manual and design sweep studies are standard features aiming to provide you with advanced automation capabilities. With the STAR Innovate add-on license, you can easily extend to optimization in order to find better designs and drive product innovation within your organization. The CAD client add-on licenses also close the loop by giving you the possibility to drive CAD parameters directly from your preferred CAD packages. But our commitment to help you deploy the usage of design space exploration to drive innovation goes beyond just CFD. With HEEDS, our multidisciplinary design space exploration solution, you can target any application using any internal or commercial software. On top of sharing the same intelligent search technology across both SimCenter STAR-CCM Plus and HEEDS, we also ensure that our design space exploration approach and philosophy between the two solutions are consistent. This helps to facilitate upgrades or mixed usage, but also allow an easier deployment and exchange of information across departments in your organization. Today's engineering problems are pretty challenging, and it's common to require multiple modeling and simulation tools to test product performance. But this is often a time-consuming manual process to transfer data. HEEDS, our multidisciplinary design exploration platform, will definitely help you apply design exploration to any simulation process, combining any commercial or in-house 1D to 3D simulation and cost estimating tool. It allows you to easily define the design workflow and automatically share data between different modeling and simulation products, as you can see on the example highlighting the use of NX, SimCenter AMESIM, SimCenter STAR-CCM Plus, and SimCenter Nastran, and also Excel. You can evaluate performance trade-offs and design robustness and focus on design selection versus design verification. HEEDS provides you with a transparent and automatic distributed execution functionality that helps you accelerate the process of testing virtual prototypes. You can of course extend the use of our intelligent search Sherpa to complex workflows using multiple and different software and applications to find better design alternatives in the allotted time, no matter the complexity of your problem or number of parameters and constraints. Advanced post-processing capabilities will allow you to easily compare performance over a wide spectrum of designs and find visible design families that exhibit desirable characteristics and robustness. This way, you can understand design performance over any number of competing objectives and constraints. Applying design space exploration to all your simulation applications and across all the departments of your organization will tremendously increase your return of investment while helping you lead the market with best-in-class products. Using the same automated design space exploration platform will also create more dynamic between departments by allowing easier exchange of information. Change is happening faster than ever, and this is a challenging time for all industries. Driving innovation with best-in-class products is the key to stay ahead. This is why Siemens PLM software is keen to offer you the right suite of tools to help you change the paradigm. You can now seamlessly democratize design space exploration and better address your challenges by having a solution that better aligns your engineering effort with the level of value extracted from your simulation process. This is the way to design better products, accelerate time to market, and reduce risk of product failures. I hope that this spotlight presentation was interesting and meaningful to you. We are looking forward to helping you be successful through the use of our software. Thank you very much for your attention, and should you have any questions, please feel free to contact us.